Okay, let's continue on with statistical process control, SPS. But in this tutorial, we're just going to look at P-chart problems. They're a little distinct from prior looking at the R charts and the X bar charts. So let's jump into P-charts. P-charts have nothing to do with drug testing. They actually refer to percentage failure or pass-fail charts. So they fit a very specific situation in quality management. So it's used when we're measuring defects that we can count. So if we take a sample of 10, let's get away from coffee cups, invoices, and we look at each invoice and say, well, this one's right. And then we pick up the next one and say, this one's right. And then we pick up one, oh, this one's wrong. And then we check the rest of them, and it's 1 out of 10. The percentage failure is 10%. So we're going to be looking at individual observations of a sample, but each observation is going to either pass or it is going to fail. And that's where we come up with percentage failure, or what we call pass-fail charts. We're still going to build a control chart. So we're going to need to calculate our UCL and LCL, and that's going to use a different equation. Every one of the 4 charts uses a different equation to derive the UCL and the LCL. So this is our target in mind, but we want to come up with what that number is for the top and the bottom. So again, we're going to be looking at attributes this time. Variables, we use X bar charts and R charts. For attributes, we either use P charts or C charts. In this case, we're going to look just at P charts, and I'll explain C charts separately. So here we go. Things that we can count, each unit in the sample either passes or fails. So you may want to think of P charts as P for pass charts versus fail charts. P charts monitor the percentage failure of a process, and you should recognize this from statistics. The little circle with a line is a sigma, so that's the standard deviation of the process, and we need that in order to calculate our upper and lower control limits. So we're going to estimate it using this fairly simple equation. It's something that my students have often make one of 2 mistakes on, so please be careful on these, and I'll show you exactly what those 2 are. But we're going to take a square root of this whole amount, which is P, the percentage failure of the process, 1 minus P divided by N, which is our sample size. Square root of the entire thing. And I'll show you a sample problem. We'll see how this goes together. Once we have that value, we can calculate our upper control limit, and it's just going to be P, the percentage for the whole process, the center, the mean, if it were, plus Z is our multiplier, and remember Z, if we want to be 95% confident or only have a 5% chance of a type 1 error, then we use 1.96. If we want to be 99.7% confident, then we're going to use a Z of 3. And the problem will tell you which ones you use. And then we'll multiply in the result of our little equation we did above. And then to get the lower, we're just going to take the same value, but we'll subtract instead of adding. So not this one, these are actually fairly simple if you keep these in mind, but I'll show you the 2 items that my students always get wrong. So let's look at this problem. The defective rate of your process is 1.5%. So immediately, that's what P is. P is 1.5. Develop the control chart for 99.73 confidence. Well, that's 3 sigma, so I know what the Z is going to be. And the sample size is 500, so now I know what N is. Now, this is where the mistake comes in, is P, when you put it into the equation, has to be put in as a decimal. So the problem said that the P, the process percentage failure, is 1.5%. That's normal. That's what we expect. But you have to convert that to a decimal in order to put it in the equation. It has to be 0.015. Convert the percentage into a decimal. If you just use 1.5, the formula absolutely will not work. So there's our formula again. We substitute in, there's the 0.015, and then 1 minus 0.015 divided by N, which is 500. This is the second mistake students make, is the square root of that entire operation. Students will often either only take the square root of the top, or they forget to take the square root altogether. So if you do this correctly, the standard deviation of our process is 0.01. We can pull up our upper control limit formula. We're going to substitute in the P, which we know as 0.015. Do not go back to the 1.5. Plus the Z, which we know is 3. And the now calculated sigma of the process, 0.01. We calculate that, and our upper control limit is 0.045, or we know in our heads that's 4.5%. So we know the mean, the middle, is 1.5%. The upper is 4.5%. We can calculate the lower. Same thing again. We're just going to use the minus instead of the plus. And we get it a very interesting number of negative 0.015. Well, you can't have a negative percent failure. So it essentially will cut off at 0. So your lower control limit in this case will be 0. That's all there is to these. I'll let you give those a try.